Today we have our topic is the law of sines. In a couple of days, or tomorrow, we'll cover the law of cosines. And these two laws, law of sines and law of cosines, allow you to work on triangles that aren't right triangles and find missing parts of triangles that aren't right triangles. And just as a review, if you have a right triangle, triangle ABC with C usually being the right angle, you can use right triangle trigonometry or any of these ratios to find an unknown side. And we've been doing that. This is for right triangles only. But if the triangle is not a right triangle, say we have, a triangle looks like this, possibly. A little bit wavy line down there, I apologize. We'll call this triangle ABC. Okay, the law of sines allows you to find unknowns, even if any of these angles aren't right triangles. And we're going to use the law of sines in a particular way. And it can be used in other ways, but in conjunction with the law of cosines, for AFAT, we have a pretty good system as to how we use it. And we're going to look at the law of sines. It's like this. A divided by sine of A is equal to B divided by sine of B, which is equal to C divided by sine of C. You could say in words that the ratio of a side to the sine of the angle opposite that side is constant in any given triangle. Now, for a fixed triangle that has fixed length sides, that's going to be a true thing. So you get a triangle, and this ratio has to hold across all three of the sides and angles. Now what you do is you use two of these three things at the same time. For example, this is the law of sines. That's how it's written. But to use it, you use, say, A over sine A is equal to B over sine B, or possibly, B over sine B is equal to C over sine C. Or there's another possibility here too, which is A over, we might as well write it down, or A over sine A is equal to C over sine C. So you can use any of these. You just have to choose two of the three. Now we're going to use this in a very specific situation, and the law of sines is used only under the conditions of two angles on one side. As given information. If you're given two angles on one side in a triangle, you use the law of sines to find the other three parts. And that's basically in all trigonometry. You're given three parts of a triangle, and you're looking for the other three. Triangle trigonometry, I should say. So we'll be given two angles and a side, and we'll be using that information to find the other three parts, the parts of the triangle, we call them. Okay, well, let's see how it works. All right, if you look in your book, the problems are given. And, these are very easy law of sines problems. And it just, this is an easy assignment. Okay, so you're given a triangle and given a 96-degree angle here, a 42-degree angle there, and this side is 12. And by the way, this is section 7.1. 7.1. All right. So the first thing you do is, so here's the given information. I'll write it down over here. Angle B is 42 degrees. Angle C, and you're given pictures of these. So, and side C is 12. All right, since we have side C, that's going to have to be a part of what we use. And we can use either of these two to find the other sides. But one of the missing parts is an angle and really you should do that first, because you know 2 out of the 3 angles, it's easy to find the third angle. Hold on just a second. Oh, I know what I did. Strike that. We'll see how this works out in a second. But that wasn't the given information. 42 here was the given information, so A was given. Turns out that B is 42 as well. I was getting ahead of myself here. Okay, so the first thing we do, if you go back and look at the book, A was given, B was not. But it turns out that you find B by subtracting the sum of 96 plus 42 from 180. I would suggest just doing it straight on your calculator all at the same time with parentheses. Yeah, might as well do that for you, just as a... Okay, 180 minus the sum of 96 plus 42. And that's 42. That's why I wrote down B as 42 here, because I was looking at my diagram and I already written it in there. Okay, so... All right, there we go. So that's the first thing you do when you find it. Okay, now you use the law of sines to find either side A or B. And it doesn't matter which one. You know, we're gonna find them both by the same technique. So we write the law of sines, and we have to use C. Remember that, because that's the only side we actually know. So I write A over sine A is equal to C over sine C. Now, isolating this for A, the only thing I have to do is multiply both sides by sine A. So it looks like this: C sine A over sine C. Now here's my suggestion. There's no reason to write the numbers into this. You can go directly to the calculation. All right, so we're going to type 12 times the sine of 42 and divide by the sine of 96. That's why we write this stuff down. All right, and there it is. 8.1. We're going to round to the nearest unit, or tenth of a unit. All right, and B works just the same way. B over sine B is equal to C over sine C. Now you could use A at this point, but use given information. So C is, you always use given information to make your calculations. So B is equal to C sine B. And this looks very similar. It's basically the same calculation, except you have just a different angle in there. But seeing how these two were both 42, B is going to turn out to be 8.1 as well. Because in different problems that angle may be different, but in this case it's the same number. So since this was an isosceles triangle, and it had to be an isosceles triangle because those two numbers were the same. Okay, number 3. Okay, so this time looks similar. ABC, and this time the given information is an 82-degree angle here and a 54-degree angle there. And we are given side A, which is 16. All right, so let's write the information down. What's the given information? Angle C is 82, angle B is 54, and side A is 16. Okay, now, it's not that this really matters, but this is angle side angle. Now, you might remember that from geometry. And this one, since we have the side we know is the same as one of these letters, that's angle side. Now, there's very little difference between angle sine angle and angle side. In geometry, there's some difference because of the proofs, if you did many proofs. But In trigonometry, there's very little difference between the two of them, because the first thing you do is find the unknown angle. When you're given two angles on a side, you find the unknown angle first. Okay, and that's equal to 44 degrees. Now we can find the unknown sides. We have to use A, and usually we'll write the A part on the right side of the equation. So your unknown goes on the left. B over sine B is equal to A over sine A. So B is equal to A sine B over sine A. All right, typing it into the calculator, and I'm not going to do it. You're going to get B is approximately equal to 18.6. Now, once you do this 3 or 4 times, you really don't even have to write this step, because it's going to end up being the same thing every time. C, and you can even think of this in your mind. I mean, you can write it down if you want. It's not going to hurt anything. But C divided by sine C is equal to A divided by sine A. So the sine C is going to have to come up here. Sine A, no, well, you can't have the same thing twice. All right. So C, approximately 22.8 degrees. Okay. And let's see, I was going to do one more, but I don't believe that is necessary because they're all more or less the same. Okay, so I'll cut the video off a little short today, and we'll say that the assignment is section 7.1. Sorry for the delay. I'll open the book and give you the page number, although you guys should be able to find that. We do skip section or chapter 6 in AFAT. Okay, so this is page 672. All right, and you do numbers 2, 4, and 6. Okay, and that's all you have to do. And I will be in touch with you tomorrow.